A climate analysis should be the first step in determining the percentage of time that passive cooling will provide comfort in the given climate. This process will also determine possible seasonal variations which may affect design. I will now elaborate on 3 effective passive cooling methods for tropical climates: natural ventilation, thermal mass cooling, and evaporative cooling. Natural ventilation is an ancient way of free cooling. It is the use of prevailing wind to achieve 2 objectives: to remove the heat generated inside our buildings and to make people feel cooler by circulating air at a certain minimum speed. Theoretically, natural ventilation widens the thermal comfort zone with the increased air velocity. The maximum cooling effect is approximately 5 degrees Celsius. So, the conditions of the climates that are suitable for the use of natural ventilation look like this. The building should have large openings on at least 2 sides for the wind to enter and exit the space. The operation of this method is straightforward. When occupants feel the indoor air is too warm, they should open their windows if the outdoor air is cooler. For thermal mass cooling, heavy mass materials such as brick, concrete, or stone are used to delay the heat gain into the indoor space during the day. The temperature of the indoor air is lower than that of the outdoor air as the heat transfer is delayed. Its peak temperature is also reduced because of the thermal resistance of the materials. However, when the heavy mass materials absorb heat, they emit heat at a later time. This results in a higher temperature at night. That is why this method normally needs a nighttime ventilation to remove the heat from the building materials for them to regain the cooling capacity the next day. The climates that are suitable for this method should have high diurnal change in ambient temperature. It is recommended for the climates with hot days and cool nights. The building should have small openings. During the daytime, when the air is too warm, the windows should be kept closed to keep the cool air inside. The windows should be open at night to allow nighttime ventilation. The operation may sound quite counterintuitive, especially for the space that is solely used during the day. So, the occupants need to be clearly informed of such operation for thermal mass cooling to work properly. In evaporative cooling, water is evaporated to cool the air. In theory, the air temperature drops while the moisture contents increase. Its cooling effect can be as high as 10 degrees Celsius or more. So, the climates that are suitable for this method should be hot and dry. Daytime spaces in hot and humid climates can benefit from this method as well. In general, any water features around buildings will have such cooling effect. Wetted pads made of fibers can be incorporated into building facades. We can design our buildings with an attached porch that forces the air to pass through these wetted pads into the spaces. The occupants need to know how to operate the systems, such as supplying water to the wetted pads during the operating hours, especially during the day. Now, how do we select a cooling method for our climate? If we combine all the three methods on the same chart, the chart will look like this. Then we need to have climatic data of hourly temperature and relative humidity. I will show you examples of three different tropical climatic zones. Firstly, in hot and dry climates, I have considered the city of Riyadh, Saudi Arabia. You can see that the weather is extremely hot during daytime hours. But we can use both thermal mass cooling and evaporative cooling to effectively cool down the air into the comfort zone. Secondly, in warm and humid climates, I chose the city of Trivandrum, India. You can see that the temperatures do not exceed the comfort zone very much. Natural ventilation alone should be able to bring the conditions into the comfort zone. Lastly, in hot and humid climates, I have taken the city of Bangkok, Thailand. This is trickier as none of the passive cooling methods can work at all times. We can analyze further, for example, into daytime and nighttime, and dry season and wet season, to select appropriate cooling methods for a certain period of time. When we cannot achieve comfort using the three methods, we would need mechanical air conditioning. To conclude, it is important for architects to understand the climate in order to select appropriate methods to avoid heat gain into the building and to encourage heat dissipation from the building. It is also important to explain to the occupants how they should operate their buildings to achieve comfort using less energy. Thank you for watching.